Up until now, we've taken a look at the different types of gate circuits. We then combine those circuits together to form other circuits. In addition, we took a look at how the computer stores memory of just one byte of data, whether that's a 0 or 1, by using a combination of these gate circuits. But your computer does one very basic elementary thing. It adds two numbers together. Well, how does it do that? In this topic, we're going to talk about the basics of the adder circuit. Let's start with the half adder. The first thing that we need to do is talk about these truth tables. I'm presenting a different look of the truth tables to you. So let me just introduce you to them real quick. Let's start down here with the AND. I think that's easier to look at than the XOR. So we know that with an AND, think about this, we have two switches. Remember walking into my house, I've got a room in my house where both switches on each end of the room have to be in the on state for the lamp to come on. If I have them in either other position or off, the light goes off. And that's what you see here with this. This would represent one of the switches. This would represent the other switches. So let's say that this is switch 1 and this is switch 2. This is the output coming out of the AND gate. So as I said, if they're both on, you can see on, then the lamp comes on, right? Any other state and they're off. Okay, so now you know how to read these. Here's the circuit. And what do you see here? All right, we see our toggle switches. We see an XOR and an AND. That's why I gave you these cheat sheets. And then we see our visual aids of having the light bulbs. Now I just have to point out again, just for clarity, that these toggle switches are just visual aids. They're just representing that other gates are feeding this particular gate. So gates feed gates. All right, what we're going to do in this, we're actually going to add. Here's how you sum, and then there's a carry bit, right? Remember? So if I'm adding 0 and 0 together, I get 0. If I add 1 plus 1 together, what do I get? I actually get 1, 0. So therefore, I get 0 here, and I have to carry 1 over to the next column. Let me just give you a refresher. I know it's been just a little while since you saw this. All right, so let's add together 7 plus 2 equals 9. So 7 is represented by 0, 1, 1, 1. The 2 is represented by 0, 0, 1, 0. So if we want to add together this one column, which is what this half adder is just one column, we would go through and we would take 1 plus 0, 1 plus 0, and what does that give us? 1. Is there a carry bit? 1 plus 0 gives us 0. No, there's not a carry bit. We're going to stop right there. If I continue adding, you'll see that I can't carry over a carry bit yet. So therefore, this half adder only gives me one solution. It allows me to just add this right column. And we'll deal with the rest of the columns here in just a moment. So let's just deal with just this one column. What we see right now is both of these switches are off. 0 plus 0 is 0, right? With no carry bit. How does this work? We know that when a switch is off, there's nothing coming out of it, so there's nothing going over here to the XOR. This dot here means that this wire is connected to this wire. So we'll come down. It's connected to the AND. See it here? It's connected to the AND. If I go to this one, same thing. I have a dot, so I can come up here. I'm connected to the XOR, and I'm connected to the AND. When the XOR has both of its inputs as 0, what does it get out of it? 0 and 0 gives me 0. And the AND, 0 and 0 gives me 0. And that's what I have. All right, let's see the next state. All right, so the next state, you notice to get through the slides, I had to go ahead and index through the adding here. Here's the next state. The switch is now on. So I have the switch on here, and the other one is off. So I'm adding 1 plus 0. I just did that here, didn't I? 1 plus 0 gave me 1. 1. Isn't that what we see right now? Right. We see that the sum has a 1 in it, and the light is on, and there's no carry bit. So we can see this. The switch is on, the power flows through to the XOR, the power flows through to the AND. So on the XOR, what do I have? I have one of the legs is on, and the other one is off. Let's go look at that. On, off, gives me an output of on. There we go. We just turned on that light. And how about the carry bit? If my two switches are supposed to be wired in series with an AND gate, what do I have here? I have on and off. Well, that then means that I'll have no power coming out of the AND gate, and that's what our truth table tells us, right? On, off. Nothing coming through it. The AND gate should be very easy for you to remember. You shouldn't have to look at the truth table. The XOR, you might need to look at the truth table to understand that one, because you're not going to use that one quite as often. Let's look at the next one. Now, all I did here was just switch it. So now A is off and B is on. So it's the same circuit. We're still adding 1 and 0 to it. Let's do the next one. So what do I have now? Let's take a look. I have both switches are on. Both switches are on. So therefore, I would be adding like this. 1 plus 1. It gave me 0 as a sum, and then I have a carry bit. See that? So over here, what do I have? 1 plus 1 gives me 0. It actually gives me 1, 0. And then I have to carry the 1. And that's what we see right here, is I'm carrying the 1. So if I take a look at this, if I have the XOR has both inputs on, that gives me an off. So therefore my sum is set to 0. It's off. The light is off. My AND now has both of its inputs on. So the carry bit is now flagged, and I have a 1 there, and the light is on. This is my half adder. But there's a problem here, and I just discussed it earlier. How do I bring this back in so that I'm able to add the carry bit like I can do here? I need to be able to add 1, 2, 3 bits together, not just one. So how do I do that? So I'm going to introduce you to the full adder. Now notice that I have the sum and carry tables right here. These are our truth tables. So when both of the switches are off, you can see the switches over here, they're both off. Notice I have a half adder, and I've just put it into a box to make it simpler for you now. So here I have the A, the B, that's the sum, and this is the carry out. And notice that I have 2 of these, and I have an OR gate. This is how I'm going to be able to bring in a carry in. So I'm able to add from a previous column. So here I can add 1, 2, 3 together and be able to come up with a sum here at the end and bring out a carry bit. This carry bit then would feed into the next circuit. So let's say that I'm just going to represent this again, so don't get confused here. This would actually wire out, come back around, and come into another circuit, another full adder as a carry bit. Okay? All right, so let's take a look at how this works. 0 plus 0 is 0. No carry bit. So I come through and I go, okay, all of these lines are off. And I get off and off. All right, let's go through. Now, I just turned on the A, so I want to add 1 plus 0. 1 plus 0 gives me 1 and no carry bit. All right, so let's see what happens. I turn this on, and what we just saw on the previous slide, if you're confused, go back, is that the sum is turned on, the carry bit is turned off. So this is actually carry out, is why it's CO, because we have a carry in. So if I come in here, I've got this one is off and this one is on. That gives me the sum. So off, on gives me an on. And that's what I see here, right? So now my light is turned on. If this is confusing to you, I want you to just take a little bit of time. Look at the truth tables and compare it to the circuit. Remember, the power is flowing in red. That's showing you the on state. All right, let's go to the next one. All I did was just switch it. Now the B circuit is on. So see, now I'm adding 0 plus 1. I don't have a carry in bit, so that's just set to 0. And what do I get? This one is turned on for the sum. It comes in and feeds the second half adder. So I get a 0 plus 1, turns that on. With an OR, I have a carry out here. That's off, and this is off. What's an OR? Oh, come on. You should know what an OR is by now. The inputs are wired in parallel. So therefore, if they're both off, then the OR gate is going to have an off state. If any of them are on or they're both on, then the OR gate would have an on state. So with this, I do not have a carry out bit. Okay, so now I've turned both of the switches on and I'm adding 1 plus 1. I'm also adding 0. So there's nothing here that's 0. Now what just happened? What do you see here? Let's walk through it. 1 plus 1 will give me a sum of 0, and I have to carry 1 over to the next column. Okay? We have A and B. We have power coming in. What comes out of a half adder with both of those turned on? Right there, 0. So this is 0. It comes up and it feeds the other half adder. These are both 0. 0 plus 0 is 0. So the light's off for the sum. Now let's do the carry bit. Both of these are on. What does the carry bit get? Come down here. There it is. Because what comes out of 1 plus 1? Pretty easy. It has a 0 that you would put in the column, and then you would carry 1 to the next column. So that's going to come over here to your OR. And if either of these are on or both are on, that's going to turn this on. That's it. That's how simple it is. I know I say that and you're probably thinking, that's not so simple. It's actually pretty simple. And if you spend a little bit of time, invest the time to see this, this is helping you to build logical thought. These truth tables, the ability to see how these different states work together is how code also works. Remember that code is just emulating what is occurring down in the computer. We do some very complex things, but once it gets broken down, this is how simplistic it is. It's bit by bit by bit, ones and zeros. That's it. All right, I'm going to give you a cheat sheet. This might help you if you get stuck and you just really want to know. You can go through, and I'm just going to go through this row by row. So if the 3 inputs are off, then the sum and the carry bit are off. If one of the 3 are on, then the sum is on and the carry bit is off. Same thing there. If 2 of them are on, then the sum is off and we have to carry 1. All right, so let's say that we are carrying 1 into the next column. 0 plus 0 plus 1 gives us 1 with no carry. 1 plus 0 plus 1 gives me a sum of 0, but I have a carry bit now. That's got to go over to the next column. And same thing here. That would be 0 plus 1 gives me a 0 in this column, and a carry bit for the next column. And then when I have 1 plus 1 plus 1, what does that give me? That gives me 1, 1. So therefore 1 goes in this column and 1 is carried over into the next column. This should make sense to you because we've already done this in binary addition earlier in this course. So what are our takeaways? For the half adder, we can add 2 bits, right? It adds 2 bits. It holds a carry bit, but can't add the carry bit from the previous column. So that's why we need a full adder. And the full adder actually consists of 2 half adders and an OR gate. It adds 2 bits plus the carry bit from the previous column for a total of 3 bits. That's what it can add. It's capable of adding that previous column. That's it. You've learned what it takes now for a computer to add numbers together. Congratulations.